Go.
Okay, go. Physics in Hollywood movies. Okay, so the first scene was from Ice Age, and there's like, I think it's Manny, Sid, and Diego, and they're all going down this ice slide, and there's this little baby named Rashawn, and then he goes off of this ramp. And to end it, once the baby goes down, they're scared he's gonna die, so then Manny catches him with his trunk. But we noticed there are some problems in this scene. First, Rashawn goes really high, and second, given this height, he should have been hurt somewhat after landing. And based on the force from landing, he also should have experienced extreme pressures.
That is a weird one.
Okay, so that was the end of this. Okay, so we evaluated 3 things. And to find the values needed, I think there are resources. Okay, so the 3 values that we mainly used was we needed Rashawn's waist size, because this would be used when solving area from pressure. And in order to figure out his age, we actually I think I might go over that later. And we also needed to know Manny's trunk's circumference, which would also be used in solving pressure, which we found was analogous to like a grown man's thigh. And we also had to figure out pressure of human skin. Okay, so the first thing we analyzed was projectile motion. And I already mentioned, given his angle of launch and starting speeds, he went very high up. And to start, we timed his flight time from the second he took off to the second he landed. And I think there was a scene where it switched the camera's viewpoint, so we just used the lap on our stopwatch. And then, yeah. Let me go to Miss Best.
Yo.
And then to figure out the starting angle, we did what Emma, Sarah, and Chloe did. We took a screenshot and then we found the angle of launch, which was exactly 45 degrees from the protractor. And we used Vimatit to calculate the maximum height vertically. And we got 207 meters, which was about, it was like 700 feet or something, and 67 mammoths. And based on this picture, we were like, that was within the t equals 1/2 range, so he would have reached his peak by that point, and this was the maximum height we saw. Then it's definitely not 67 mammoths. But even if that is true, we kept moving on and went to impulse and momentum. And given his height and speed, we thought he should have experienced extreme impact when landing. So we solved for changing momentum. We had the mass of both a 12-month baby, which we figured out because he learned how to walk in the movie. And the average age that babies learn how to walk is 12 months. And the mass of a mammoth was not hard to find. And then we timed the impact time from when Manny catches the baby to when the force stops. And we timed that 5 times, took the average. And then we solved this change in momentum. We set it equal to Ft, as this equals impulse. And we had the impact time. So then we found the force was 818 newtons, which is very large. But we kept moving on to pressure. And we solved pressure equals force over area. And we had force. We just had to find area. So to we calculated force already. And to calculate area, as I mentioned earlier, we figured out he was 12 months old, so then we looked up average waist size of 12-month babies. And we found that was 19 inches. And then I had to look up average circumference of a man's thigh. And then that was 24.5 inches. Yes.
Did you not think it would be more accurate to just measure a man's thigh?
Well, we
No.
weren't
She
sure
would
if
need
that
a
would
very large sample size.
exactly. So we figured it would just be better to look online rather than find a bunch of grown men. Find the circumference. And then using these circumferences, we solve for radius, as that's in the 2 pi r formula. And then we found for diameter. And then we could solve diameter equals length, and then the other diameter equals width, and then we solved area. And the pressure experienced by the baby was 26,000 pascals. And the pressure of, before getting like at least some sores on your skin, is between, I think it was 1,600 pascals and 6,700 pascals. So that's 26,000, 26 times that. Okay, and based on these formulas, we figured out that the vertical distance traveled was way too much, given his speed and the angle of launch. And even if he did approach this height, he should have been harmed after landing.
So the next scene that we did was from Finding Nemo. So in this scene, Marlon and Dory are asleep in a pair of scuba goggles, and the goggles are hanging on the edge of a large yacht. When they shift the goggles, just like a teeny tiny bit, when they shift the goggles, the yacht fully tips over. And so the problems with the scene is that the goggles are so small compared to the ship that it shouldn't have, we predicted that it shouldn't have exerted that much of a torque and force on the big yacht. And then afterwards the goggles fall. And the goggles fall at, like when we watch the videos, we realize that it's very fast for how they should have fell underwater. So we appeared that it'd be too fast. So I cued it. Okay, so this is the beginning. As you can see, it's hanging off.
Oh, this is actually a really good scene.
Thank you. Thank you.
Did you film this?
No. And then you can skip a little bit. So when he moves it that much, the entire boat moves. So we're like, okay.
And then eventually crashing down.
Just swim to the side.
So it moves that entire way, and then wait for the goggles to fall.
Okay. Marty, you have to go to the guidance office.
Okay, Miss Cooper.
And then look down. It's falling like, we're like, okay. So, you can pause it now. So what we've approached this with was, so first to research values, we looked up on Amazon a scuba mask, and from there we found the mask and the length of the goggles frame. In addition, I looked up in boatinternational.com. I found what supposedly, so first I looked up different images of different types of boats, and even though it was a little like, I don't know if it was, oh yeah, even though it was like